When we look up at the night sky, it's so easy to let our imaginations run wild, right? We immediately think about distant, undiscovered planets, or maybe lunar bases, or astronauts floating around in zero gravity. We've completely romanticized the idea of looking outward. But honestly, the truth about modern space technology is actually way more grounded and, frankly, a lot more critical to our daily lives down here. In fact, some of the absolute most vital, cutting-edge space missions happening right this second aren't looking out into the void at all. They're pointing their incredibly powerful cameras and sensors straight back down at us. And that's exactly what we're diving into in today's Explainer, how turning our gaze away from the stars and back toward our own planet is actually the key to saving it.
I know, it kind of sounds like a concept pulled straight out of a sci-fi novel. We've got these machines orbiting the Earth at 17,000 miles per hour, literally suspended in a freezing vacuum hundreds of miles above our heads. Yet somehow, those distant machines are actively dictating how a farmer plants a single seed or how a massive cargo ship navigates a stormy ocean. So today, we're going to explore exactly how satellites are solving these incredibly complex environmental and economic challenges on the ground. We're talking concrete, measurable improvements in everything from the food we eat to the air we breathe. We're essentially watching Earth from above to save millions of dollars and protect nature at the exact same time. And the invisible, magic ingredient making this all possible? It's data.
But here's the crucial thing to understand. Data, much like electricity back in its early days, has absolutely no intrinsic value until it's transformed into actionable insights. A recent World Bank report drew this brilliant comparison between our current data revolution and the initial rollout of the electrical grid back in the late 19th century. Think about that for a second. It took decades to lay all the cables, build the power plants, and establish the grid before someone finally invented, say, a toaster or a washing machine to actually use the current. Well, we've spent the last few decades launching satellites, laying the cables, so to speak. But right now, we finally entered the appliance phase of the data revolution. The infrastructure is there, and massive streams of information are finally being harnessed for incredibly powerful predictive analysis. So data is the fuel, but we really need the right engine to burn it.
So, what exactly is that engine? Well, it's called Earth Observation, or EO. Simply put, this is the gathering of data about Earth's physical, chemical, and biological systems using satellites. But a raw satellite image of a cloud or a piece of farmland just isn't enough on its own. It absolutely relies on a trifecta of modern computing: big data, analytics, and artificial intelligence. Think of it like this. Big data is this giant, chaotic haystack of information constantly raining down from orbit. Analytics is the superpowered magnet pulling out the needle from that haystack. And AI? That's the highly sophisticated machine that turns that single needle into a usable tool. Together, they take massive amounts of space-gathered data and process it into hyper-specific earthly solutions.
And when we actually analyze the real-world value of Earth observation, we see it driving massive innovation across 4 major global sectors. Based on detailed findings from the European Commission, EO is no longer just an academic pursuit or some theoretical science experiment. It's a serious, heavyweight economic driver. We've got concrete, highly profitable use cases in climate change monitoring, agricultural yield management, oil and gas safety, and maritime operations. The applications are super broad, but the results highly specific. Let's actually break down the numbers to see just how impactful this is, starting our journey out on the open ocean.
By using Earth observation data to dynamically model shifting ocean currents and weather patterns, the maritime sector is optimizing vessel routes in real time, and they are seeing up to an 8% cost savings in fuel for European adopters. Now, to put the sheer scale of the global shipping industry into perspective, these vessels are massive, sometimes carrying thousands of containers across entire oceans. Slicing 8% off the fuel consumption across these giant cargo ships doesn't just represent a monumental financial win for the logistics companies, it's literally the direct equivalent of taking millions of gas-guzzling cars off the highway overnight. We're talking about an immediate, massive drop in greenhouse gas emissions and heavy fuel pollution over our oceans.
Okay, bringing this technology from the oceans back down to the dirt, let's talk agriculture. Smart analytics driven by space data are increasing crop yields and saving heavily on expensive nitrogen fertilizers, creating a net economic benefit of €5 per hectare. Now, €5 might not sound like a huge victory at first glance, but multiply that by the millions upon millions of hectares of farmland globally, and it's staggering. The real breakthrough here is the contrast between the old way and the SpaceTech way. Historically, farmers kind of had to guess, often blanket spraying entire fields with chemicals to ensure growth, which caused highly toxic runoff into our rivers. Today, satellites act like precision doctors, diagnosing the exact needs of the soil meter by meter. Farmers know exactly where to apply nutrients, boosting their yield while radically shrinking their environmental footprint.
Now, the financial and environmental stakes get even higher when we look at the oil and gas industry. An undetected offshore oil spill can utterly destroy an entire coastal ecosystem for decades, collapsing local fisheries and just devastating wildlife. But early oil spill detection monitoring from space helps save roughly 25 million euros annually. And guys, this isn't some experimental future tech. This system has been actively saving our oceans since 2011. By using high-res satellite imagery and AI to constantly, tirelessly watch the oceans, we can spot the chemical signature of a spill the exact moment it happens. This allows companies to deploy emergency cleanup crews way before a minor leak becomes a sprawling, unmanageable catastrophe.
Finally, in the realm of climate defense, by reducing the uncertainty in sea level forecasts by just 25%, we are saving up to 100 million euros every single year in coastal protection. Just consider the incredible cost of building a massive seawall or engineering complex flood defenses for a major city. When governments and city planners have highly accurate predictive models of how storm surges are actually going to behave, they can tailor their infrastructure perfectly. They prevent wasting massive amounts of taxpayer money on over-engineered infrastructure while making absolutely sure they aren't underprepared for incoming disasters. Space data is quite literally dictating the blueprints for how we build our shoreline defenses.
So that wraps up Section 1, Oceans and Farms, and how we're optimizing the Earth.
It's honestly amazing when you stop and think about the sheer logistical marvel of it all. We take this abstract, invisible data floating in orbit and turn it into the precise amount of fertilizer dropped onto a specific patch of farmland through tools like FarmStar. FarmStar is a stunning example of this translation process. It's a specialized service that pools the aerospace expertise of Airbus with agricultural institutes to offer satellite-based information directly to the people growing our food. A satellite in the freezing vacuum of space is literally communicating data that informs a muddy tractor driving through a field in rural France, right in real time. This perfectly captures the essence of Industry 4.0, taking a digital stream of ones and zeros from space and transforming it into a physical, biological reality down here.
Moving right along to Section 2, preventing disasters through early spill detection.
Because it's not just about optimizing daily operations and trimming budgets. This orbital technology serves as our ultimate planetary alarm system. Earth observation networks provide unblinking 24/7 oversight of expansive pipelines that stretch across incredibly isolated, hostile terrains. We're talking thousands of miles of infrastructure running through frozen tundras, dense jungles, and scorching deserts, places where it is just physically impossible for human crews to patrol effectively. Space-based monitoring isn't just a nice-to-have upgrade here. It's an absolute necessity. If there's a pressure drop, a rupture, or an unexpected thermal anomaly, the satellite network flags it instantly. It's a proactive, global defense mechanism that actively mitigates ecological disasters before they spiral out of control.
Which brings us to Section 3, the changing guard of space tech and this entirely new era of innovation.
Just look at how things have shifted. Since 2010, the commercial Earth observation market has just exploded, boasting a really robust 11% compound annual growth rate. What's truly remarkable here is the massive surge in private enterprise demand. For decades, the space economy was totally dominated by defense and security, governments spying on other governments. But today, the enterprise sector is expanding rapidly right alongside them. This is a monumental shift in the global market. It tells us that private commercial businesses, from shipping conglomerates to massive agricultural co-ops, are deeply hungry for this data and are eagerly paying for the insights the cosmos provides.
Historically, especially during the Cold War, the space industry was driven entirely by gigantic government monopolies. You needed the billion-dollar budget of a superpower nation just to launch a radio beacon into orbit. But today, we're witnessing a complete democratization of analytical power. Private tech startups are launching networks of cheaper, highly capable satellites. Some of them are no larger than a shoebox. The emergence of these agile private actors has completely shaken up the traditional markets. You no longer need to be a state-sponsored space agency to access orbital data. Agile tech companies are grabbing this raw data and building massively impactful, scalable applications for almost every industry on Earth.
And that leads us perfectly into Section 4, building a circular future through sustainable innovation. Because all of this technological evolution inevitably drives us toward what experts call a digitally empowered circular economy. By combining big data, analytics, and AI, we fundamentally enrich how we make decisions. We dramatically reduce defects, cut emissions, and lower energy consumption. And this builds a highly coveted state known as sustainable competitiveness. It's so vital to understand that utilizing space tech to go green is not merely some charitable, feel-good environmental endeavor. It is a ruthlessly efficient, highly profitable business model. Companies are waking up to the fact that they can maximize their profits not by relentlessly extracting more raw materials from the Earth, but by using space data to be radically more efficient with what they already have.
So I want to leave you with this final critical thought. Now that SpaceTech gives us the exact granular data we need to save millions of dollars and actively protect the natural world, how will we choose to act on it? We really no longer have the comfortable excuse of ignorance. We can dynamically map the ocean currents. We can measure the health of a single crop from space. We can spot chemical spills the second they happen, and we can predict the rising seas. The data is flowing. The analytical engine is running. The insights are right there on the dashboard. The ultimate question now is whether our businesses and our governments will fully embrace these incredible tools to build the sustainable circular economy we so desperately need.